Now we have seen till the fetch is over, decode is over, and then the effective address calculation is over. After that, depending on the type of instruction, we have to take care of execution. Now let's try to execute instructions which are related to memory reference. So there are three types of instructions, right? Memory reference instructions, IO, and register. Let's try to execute the memory related instructions first. So how do we know that they are memory related instructions? By looking at the outputs of the decoder. If you look at the instruction decoder, which bits are used by the instruction decoder? If you have the instruction register, the first bit is nothing but the addressing mode, and the next three bits, right? So if you assume that this bit is 15, the next three bits are 14, 13, 12. These three bits are going to determine what type of operation it is, right? If this is 0, then it will be D0 will be activated by the decoder. So when you give these three bits to the decoder like this, it is going to give us 8 outputs, right? And one of the output is going to be highlighted. Depending on the type of instruction it is instruction register, one of them is going to be highlighted. If D0 is going to be highlighted, it means that it is this instruction. If D1, it is this, D2 is this. So therefore we can easily identify what type of operation it is while we decode it. And already decode is over. Even after decoding, we have finally we have executed one phase. So using that phase, we have the effective address now present in address register. Therefore whatever is present in address register, that contains the address at which the operand is required, operand is present. In case if operand is required, then we are going to access the memory using the address register to get it, right? So now we are left with two things. So fetching is over and decoding is over, and effective address computation is over. Now we are left with two things. What is it? Fetching the operand and executing the operation. Now let's call both of them as execution itself. In most of the computers, they generally write it separately, saying that fetch operand cycle and then execute cycle. In most of the computers, they do it separately. But here we shall put them together. The reason being, we don't, for every instruction or for all the instructions, we don't need fetch phase. That is why I am just putting them together. Okay, now let's see operations one by one. See this one. So what are the timing signals that are over here? T0, T1 are over here, and T2 is over here, and T3 is over here, right? So for the memory reference operations, all these are over. So by the time you come to execution, what is the timing signal that is running? T4 is running, right? So now how can we identify that we are in execution phase? If you look at T4, we can identify that we are in the execution phase. Got it? So what is that I am going to write is, if we are in T4, and how can you identify what type of operation it is? Depending on the outputs of the decoder. If T4 and D0, now what can you say about it? If it is T4 and D0, I can say that we are now in the execution phase of the operation or of the instruction add, isn't it? Of the instruction and. So we are going to execute and. In order to execute and, we should check these two conditions. The timing signal should be T4 and the type of the instruction should be D0. Now, should I also verify what type of addressing mode it is? I need not verify it, because either it is direct or indirect. The difference has been already dealt in T3. That is why for direct addressing mode, T3 is left blank, so that you need not worry about the instruction mode anymore. In case if you start executing the direct instruction at T3 itself, then we have to even check if it is direct or indirect. Depending on that, we have to take the actions. But just to avoid that overhead, we have left the direct addressing mode blank in T3 timing signal. Therefore, in executing this hand, there is no direct phase. Got it? So there is no need of seeing this I bit at all. So if this is the case, what are the things that we should do? First thing is, one of the operand. So for this one, and generally requires two operands. We always assume that one operand is already loaded prior to this instruction, and so AC will contain one of the operands and the other operand address will be given by the address register. Therefore, in the address register we have the effective address. We have to go to the memory and fetch it first. So first we have to go to the memory, and using the address which is present in the address register, we have to fetch the required operand into data register. Got it? So how do you think that this particular operation will be performed? We know that if this is the memory unit, if this is the address register, already address register is connected to memory. Therefore, you need not give any signal to send the address there. It is already given, right? And so already the word which is present at the given address in AR is already highlighted. Only thing you should do is we should move this onto the bus, right? So how can we move this onto the bus? By giving the select lines here as 111. Then memory will be selected, or the word which is highlighted by the address given in this will be kept onto the bus. Got it? So once that particular word is on the bus, we have to load it into data register. Got it? This has to happen. For that reason, what happens is we'll take this, so T4 D0, and we'll apply it to the logic gate and we give this to all these three through OR gates only here. Therefore 111 will be selected, which means whatever is present in AR is already in the memory. Therefore that memory particular word is already highlighted. That particular highlighted word will be here. So whatever is in the memory will immediately come onto the bus. Got it? And at the same time we have to even enable the load of DR, which means this particular signal will also be given to the load of DR. So this is how the circuit has to be made. Got it? So if this is done, then what happens is, I told you that let us assume that this is the T4 timing signal. This is the clock which is applied to all the devices, and this is T4, right? So what happens is, during this initial phase, the memory word will be transferred onto the bus, and at this positive transition at the end of the at the end of the timing signal, right, at this particular positive trigger, this particular load will happen. Therefore by the end of the timing signal T4, the required word will be present in DR. Got it? And now after this, what should we do? At T5, if it is D0, which means already we have moved one of the operand to data register. At this point we have to enable or give the proper signals to the adder and logic unit which is already present in order to perform the ANDing. So we enable that AND logic, or the circuit which is responsible for ANDing, we enable that, and to that we are going to provide the DR and AC, right? So DR and AC we give them as input, and then the output will be stored on AC. Assume that this particular operation, and one more thing, when I am writing like this, it means that the time required to access the memory is equal to or less than the timing signal T4, right? Here that is just an assumption. In most of the cases memory will be very slow, therefore sometimes it might require more than one timing cycle, one signal, which means more than one clock. But in this case, just assume that in order to access the memory, one clock signal is enough. That is just an assumption. Got it? And at the same way, assume that we will be able to select these two inputs directly and send them to the ALU, and ALU will be able to process this operation and write the result back in just one timing cycle, right? So which means in one clock cycle ALU is able to perform this operation, and in most of the cases it is true, right? So what are the assumptions here? I'm assuming that this can be performed in one clock cycle, and also this can be performed in one clock cycle. Got it? So the required operation is over. So if the required operation is over, now if I have to start the next instruction, which means the instruction AND is over. So if you observe it, in order to execute the instruction AND, it has totally taken T0 to T5. So how is it done? T0 and T1 are for fetch, T2 is for decode, T3 is either it is going to be idle or it is going to compute effective address depending on what type of addressing mode it is. So anyway, T3 has to be there, and T4 is actually used for fetching the operand, and T5 is actually used for executing, right? Executing the instruction. So by the end of it, our execution is over. So how many clocks are taken in order to finish this instruction? So AND instruction has taken, if you observe this, 6 clocks. If every timing signal is going to be there for 1 clock, see this is the clock and this is the timing signal, right? So it has taken 6 timing signals, and we have known that we know that every timing signal is going to take up 1 clock. Therefore the total number of clocks which are required in order to implement this particular instruction AND is 6. 6 clock cycles are required, right? T0 to T5. Now after this, if I just leave it like that, our instruction execution is over. If I leave it like this, then the next clock will be T6, right? But then we don't want T6, we want to start fetching the next instruction, but we have designed the hardware in such a way that fetching will happen only when it is T0 and T1, right? So someone has to clear the sequence counter, so that from T4 the next one produced will be T0. Are you getting this? If you look at the sequence counter is connected to the decoder, and the decoder is going to generate from T0 to T15. Now we have now reached till the point T4, T5, and if you leave it like this, T6 will be immediately enabled, right? Which means after this one becomes 1, the next one which becomes 1 will be T6, but we want to go to T0 again. Therefore it is our responsibility to see that after the execution of every instruction we should reset this sequence counter. So for that reason we are going to apply clear. There will be a clear input given to the sequence counter, and that clear should be done. So which I am going to write as SC is going to be 0. Got it? So at the end you are going to always make SC to be 0, so that the next instruction which starts is going to start from T0 again, right? So this is how each instruction will be executed. Got it? So just for the sake of explanation, I've taken every detail while explaining this first instruction AND, but for the remaining instructions I'll just write briefly, but I'm not going to explain you in this detail. So since you understood one instruction, all the instructions will be same, right? So for all the remaining we shall go fast. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.